Suppose we are to delete this node from this doubly linked list, that's node number 3, right? So for deletion of this node we would need one pointer to traverse to this position and then to delete that node or free up the space allocated for that node, right? Then we would need additional 2 pointers, one to keep track of the address of this node, that is node previous to the node to be deleted, and one pointer to point to this node, that is node after the node to be deleted. Although we can do this without these 2 pointers, that's the pointer pointing to this node and this node, but then at your level that will become difficult for you to understand, to comprehend. So, and there is no harm to use these pointers for understanding purposes, so we'll use them, right? So first we need to reach this position, right, from this position. So this is position number 3, and we will need one integer type variable to store the position to be deleted, right? So let us start. We will use one integer variable. Let us name that int index and initialize that to 1, right? And then we would use a pointer to traverse to this position, and we would use the same pointer to delete or free up the space allocated for this node. So we will name that pointer as traverse and del. So we'll say struct dbll star traverse and del, and initialize that to head. And with this statement, with the execution of this statement, we are achieving this. We are making another pointer which we name as traverse and del point to the first node, right? And then we will advance this pointer to reach this place, and this is the way to do that. We will say while index less than 3, advance this pointer. We'll say traverse and del equal to traverse and del fptr. That means with the execution of this statement, traverse was pointing to this. Now with the execution of this statement, traverse will point to the node, the address of which is contained in traverse and del fptr, that is this, that is it will point to this node. So now after the execution of this statement, this traverse will point to this node, and then we will increment the index. We will say index equal to index plus 1. Now at the first place index was 1. Was 1 less than 3? Yes, it is. Then this statement got executed, and now traverse points to this. Index by this statement becomes 2. And is 2 less than 3? Yes, it is. Then this statement will again be executed. Now what will happen? This traverse will no more point to 2, but it will straight away point to node number 3, that's position number 3, which we are to delete, right? So index will become 3. Index will become 3. Once index becomes 3, is 3 less than 3 in the next iteration? No, it's not. Then these statements won't be executed and control will come out here, right? So after control comes out of this while loop, this we have made this traverse and del pointer point to the node which we are to delete, right? Now if at this moment we use free traverse and del statement, then the space allocated for this will be deleted and we will lose these links. That means we will lose track of this node, which we do not want. So to not allow happening that, we will have to use a pointer variable to keep track of this node, right? And then we have to make this forward pointer of this node, that is node previous to the node to be deleted, point to this node. So we will need another pointer which will keep track of this node. So the pointer to keep track of this node, we will name that as preserve previous. That means preserving the address of the node previous to the node to be deleted, and we will name the pointer which will hold the address of this node to be called as preserve next. That is, it will preserve the address of the node next to the node to be deleted. So we will use two pointer variables. So one will be struct dbll star preserve previous, and we will initialize it to null. Then another struct dbll star preserve next, and we will also initialize this to null, right? Then here we have to use these pointers. So now currently this traverse and del points to this, and how can we manage the address of this node? Simply by the statement traverse and del arrow operator bptr, and the address of this traverse and del arrow operator fptr, right? So we will assign the addresses of these two nodes to their respective pointers. So we'll say preserve previous equal to traverse and del bptr, right? So now this, wait, and then preserve next equal to traverse and del fptr. So these statements, what do we achieve by the execution of these statements? We achieve this. We make another pointer called as this preserve previous point to this, and another pointer variable, namely preserve next point to this, right? Now we can restructure the links. So we can say we have to make this forward link, pointer of this node point to this node. So we will say preserve previous. So we will say 0 previous fptr equal to preserve next. Now with the help of this statement, now this no more points to this, but this will straight away point to this. Now you will have to make back pointer of this node point to this node, not to this node. So we will say preserve next bptr equal to preserve previous. Preserve previous. With the execution of this statement, what we achieve is this back pointer of preserve previous no longer points to this, but it will straight away point to this, right? Now we have established these links. Now the time comes to free up the space reserved for this node. So we will say which pointer points to this. We know it is traverse and del. Now we will use this statement. We will say free traverse and del, right? So with the help of this statement, what happens is this node does not exist now, right? So we have managed to delete the node at this position, and likewise you will be able to delete any node from any position in between the first node and the last node of a doubly linked list, right? So I hope this must be very clear to you now. So go through this once again, try to understand this, not to remember. I mean, there is no point in remembering the program for a specific situation. You have to understand things, and then you will be able to do any program, and then sky is the limit if you understand things in its proper perspective. And you should not get frightened when it comes to programming. Try to understand things. That's the key to learn programming. Thank you very much. Let's meet in the next lecture, inshallah. And you can always assign null to these pointers, traverse and del, preserve previous and preserve next, so that they don't point to any node, because you do not need them at all. Thank you very much.